So, for our project, we decided to make a machine learning model that will hopefully predict the mid-cap to large-cap U.S. stock prices every day, or can be used to do that, I should say. And then we chose mid to large cap because those companies are generally less volatile, and therefore it's easier to get predictions for them. Um, and the methods we used, here, I'll let Cooper talk on that.
So we used a supervised machine learning algorithm called support vector regression. And so a supervised learning algorithm just means that the model gets fed data along with the answers, and it's able to make a prediction using the data and then look at the correct answer and see how far off it was and be able to make adjustments to make further accurate predictions the next time. Support vector regression also uses kernels to help shape the hyperplane, which is a divider between the two sets of data and how it makes the prediction. Kernels are just a set of mathematical functions to transform non-linearly separable data into linearly separable data. We use three different kernels: linear, polynomial, and the ratable basis function, or RBF, to compare and find out which kernel performs the best for stock prediction. As inputs for our for our model, we use technical analysis indicators. And technical analysis is done in the stock market to try and forecast the direction of future stock price movement. So we used 5 different indicators that each one indicates something different, whether or not the stock is likely to be overbought or oversold, the strength of a current price trend, whether or not the price trend is likely to reverse or not. And it calculates all those and feeds them into the model as input.
So the way we're getting the data for our technical analysis indicators and to feed our model is there's a Python library that we found very conveniently that is able to pull data from Yahoo Finance, their stock data for every day, that's updated every day. So we have an example here where that is the data it's part of the data. It just shows like the first couple and then the last 5 or so for the Ford stock over the past 15 years. And then with that, we were able to feed the technical analysis indicators and use those for our functions. Part of the SVR model and the kernels is that we have different hyperparameters that we have to optimize in order to get a better prediction model. So the paper that we looked at before, trying our own hand at it, didn't say how they optimized their hyperparameters all, but they did. So we decided to go with the Bayesian method of optimizing our hyperparameters and used that to help get our results in our prediction model, which our results, we used root mean square error and mean average percent error in order to see how successful we were, which mean average percent error is essentially on average how percent-wise are we off. And that's the one we really focused on because for stocks it doesn't matter as much if I'm $1 off as depending on the stock. A dollar might be really good or a dollar might be horrific. So mean average percent error is a lot better because it gives, you were 2% off. And we were able to come to a prediction for linear. On average, we got about 2.5% error, and that was the best one kernel-wise that we were able to get, which is not good, really, because stocks usually don't go up or down 2%. So, but it is better than the study we looked at, which seemed to have higher for everything, especially the others. Linear less so, but still higher overall.